Okay, good afternoon, everyone. I think you are able to hear my voice. Only 17 members are there. So this is a topic we are going to see. I think you are able to see the screen. Please reply in the chat box. Are you able to see the screen as well as hear the voice? Okay. Now let us go in the previous topic. Yesterday we had an introduction about this topic. Now for the first frame, see here, this is the first frame here, frame S, and here the second frame, S prime or S dash. Okay. Now here we considered both the frames were initially at point O. Okay. Thereafter, this particular frame, second frame has moved. Okay, through certain distance here. So it reached a new place here. Okay, it started from point O, but now it reached at point O dash or O prime. Now actually this particular second frame is moving. So instead of frames, you can consider two objects. Consider this as bike 1, this as bike 2. Initially two bikes are there at point O. Okay, thereafter the first bike is stationary and second bike moved, okay, with some velocity v. Okay, that was the thing we had explained in the previous class, and thereafter we had given a short explanation for that representations. Now we will continue the previous explanations. Okay, now for that let me go with the derivation part. Small derivation we need to derive, very small derivations, no need to have heavy mathematics. Let me clear one thing. I mean, I need to get clarity whether are you able to hear my voice or not? Are you able to hear my voice? Few members said it is clear. 103, 123, 107 said it is clear. So I hope it is clear to all the other members. So let us continue here. Okay, let me check with other images what are available. Okay, now this is the image we are going to refer to understand the concept. Now two persons are there at point O. Initially the second person is also considered to be at point O. Okay. So here initially S and S dash will be concentrating on point O. So this will be the point O, here the origin. So initially both the frames will be at point O. So they will be concentrating at the same origin. So at that particular time, T value will be considered as 0. T will be 0. So at T equal to 0 means both the frames are concentrating on the same origin. Now later on what we are explaining here, the second person, whatever the second person is there, he moved from point O. Initially both persons are there at the same point. Now the second person moved, okay, with some constant velocity v. Okay, so instead of persons we are mentioning it as frame S and S prime. Now both these persons are going to view particular event. We mentioned this as an event. Let us assume that a particular vehicle is there. Okay, so they are observing this particular vehicle. Let us assume this as the event as a vehicle here. Some bus is moving or some vehicle is moving or it is at rest. Okay, so both the persons are observing the same particular point. Okay, now I'm repeating here the importance of the topic. So we are considering initially two persons concentrating on same origin. So if they are at same point, then the time will be considered as t equal to 0. Now thereafter what we said, the second person is moving with some constant velocity v. Now in this diagram, he is moving along x direction. Okay, this diagram represents the frame is moving only in the x-axis. Okay, but we are going to take three-dimensional diagram. Three-dimensional in the sense, instead of this particular point, the frame will be somewhere in this some other point will be there that I will show. Okay, so what is the thing here? The second frame is moving on the x-axis here. Okay, there is no change in y and no change in z. Okay, this is one of the point. Now we are going to change this particular frame moving along x, y and z. Okay, so here event means both the persons are observing a particular object or any. So what is the difference between the first and the second frame? So second frame has moved, okay, with some constant velocity v. So as the distance is there between these two frames, you can calculate the distance. Okay, as you can have the equation or the velocity can be written as distance by time. Velocity is given as distance by time. Now what happens to the distance? Distance equals to velocity into time. So that we are mentioning here. So this particular second frame has moved with some constant velocity v for a particular time t. So then the distance of separation between these two is nothing but the product of these two. Okay, So you multiply the velocity and time, you will get the distance of separation between these two frames. Okay, now we will continue. Now here, instead of the persons, we are considering these images. Now this is the first frame, this is the second frame, frame number 2. Okay, now here we are considering a point P as the event. Now from the first frame, okay, frame S. Now the position of the point P. Now let us go with the pen. Okay, now from here we are observing this particular point P. We are observing the point here. Okay, now thereafter we will observe the same point from the O dash. Now if you go with O, this point, okay, up to point P. Now how can you give the position here? It is given by R. Okay, which is a vector here, the position of this particular point P from point O to point P. Okay, so now here it is given in terms of the coordinates x, y, z and t. Okay, this is regarding the first frame, the coordinates in terms of the first frame. Now the same point P, which is observed from the frame S bar or S cap or S prime. Okay, now the coordinates now we are going to give as x prime, y prime, z prime and t prime. Now here t and t prime are same because at the same time we are going to observe both the events at both the frames here, both the frames. So t dash will be equal to t. So either you can mark this as t dash or a t bar here or t prime. Okay, but the thing is that both the time periods are same because at the same time you are observing the event from S as well as from S prime. So that's why you will take t equal to t prime. T equal to t prime. Okay, what is the reason? We are observing at the same time. Now depending on this, we had small derivation that we had seen yesterday. Now let me go with the matter that we are going to write in the notes. Now you observe here. Now this particular frame has moved, okay, towards y, and there is a movement towards z also. Okay, this diagram might not be clear to understand because this is a two-dimensional diagram here, but you need to consider that the frame has moved in the 3 dimensions. In the previous diagram, what we had seen that it is only along x direction. If you can refer to this diagram, okay, there is a displacement only along x direction. Okay, this is a only displacement. Now what we are doing here, we are moving the frame into the 3 dimensions. Let me go with this. Okay, let us see here what is the thing going on. Now first you draw the first frame. Now let us consider this as the first frame here. Now instead of x-axis, if you are going with this direction, it will be the x-axis. Now instead of this, what we are going to do, we will consider somewhere, okay, like this. Okay, consider like this. So the frame has moved along y and as well as some z direction, and from both the frames, let us consider a point is there, a common point is there. Okay, we are going to observe a common point here. Consider this as point P. This as point P. Okay, this point we are going to observe, this particular point. Okay, this is point P. Now that is a thing we are going to draw in the concept while explaining. So now here, let us go with the explanations. Okay, now observe, we are considering two frames, frame S and S prime. This is S prime. Now here, the black color frame is the first frame having the origin O. This is the origin O here. Now the second frame is there at the origin O prime. Now what we mentioned here, the second frame has moved with some velocity. It is a constant velocity, uniform velocity, okay, with some v. Now for a particular time period of t. Now how can you give the distance here? Distance d can be given as what? Distance can be given as velocity into time. Velocity into time. It will be the distance here. So this is the distance we mentioned here. So this is the distance we had mentioned. Now as if we refer towards the x-axis, there will be the suffix as x. Okay. Now similarly here, there will be the distance of separation vt, suffix here y, towards y direction on the y-axis. Next, similarly, a displacement along z-axis as vt. So here z represents the z-axis here. So now let us go with the other important points here. I think you are getting the points. Okay. Now here you refer to the diagram. So what is x here? What is x? Small x is there. Now x is the distance between the first frame and the point P. So this is the distance. So x here, okay. Now x prime is there. X prime is there. It is the distance between the second frame and the same point. Okay. Now that is regarding the x-axis. It is regarding the x-axis. Now if you go with the comparison with y-axis, okay. Now y here, this is y. Y is comparing regarding the y-axis. So it is the distance from the frame and the point towards y-axis. Now this is the second frame, distance between the second frame and the point in second frame. Okay. Now similarly, third one I didn't wrote here, but you need to assume that third one will be there. So to avoid confusion, I didn't mention those things. So you need to consider x. Okay. Now x prime. It takes small x. Okay. Now here y prime. Okay. Next z that I didn't wrote in this particular image. You need to consider those are there. Now z prime. So these are small letters. Consider these as small letters. Okay. Now what is x here? Refer back. Now x is the distance between the first frame, okay, and the point P. Now what is x dash or x prime here? X prime is the distance between the second frame and the same point P. Now similarly, the other two, y and z. Okay. Now let us go with the explanations remaining inside the explanation or the topic. Now what is the important point? Initially consider the first frame at rest. Okay, S is at rest. Now second frame we are considering, second frame is moving with some constant velocity. Okay, that we had shown in the diagram. We had shown the same thing in the diagram. Okay, it is moving with some velocity. So this is the velocity here, and the direction also we had given. So this is the constant velocity. Okay, now the same points you are going to write. Consider an event in the sense some point P, okay, takes place at point P. Now that is observed from the both the frames. We are going to observe the same point or the event from both the frames. Let an observer is at point O of the S frame, and the second observer is there at origin O dash or O prime in S prime frame. Okay, now refer to this what I mentioned here. What is t equal to 0? If both the origins are at same point, if they are coinciding, then that particular time is considered as t naught. Okay, both the origins will be coinciding, means at that particular time will be t naught. Now next points what we wrote here regarding the coordinates. Okay, so if you refer to the diagram, you can write the sentences. So now here, what are the coordinates of P in S frame and S prime? So here regarding S frame, you are getting X, Y, Z and T. Now regarding the second frame, you are going to get X prime, Y prime, Z prime, T prime. So instead of T prime, you can take T because both the time periods are same. Okay, at the observation of event. Okay, so that's why you can take it as T prime as equal to T while applying in the derivation. Now what we are going to find, we had got the diagram and the important points. Now what we are going to do, so that is the point here. So now here, what is the thing, we are going to find the relation. We are going to find the relation between the coordinates, okay, between the coordinates of point P. What are the coordinates we are having? We are having coordinates in S frame as well as S prime. Okay, so what are the coordinates here? So these are the coordinates. Now here X, Y, Z, T are the coordinates in S frame, and here S prime, Y prime, Z prime, T prime. Okay, between these coordinates we are going to find the relation, okay, in this topic. Now let us go with the next page. Okay, now refer to the diagram. Let me go with this, the first image itself. Okay, now here this is the diagram. Now X, what is X? It is a distance from the first frame to point P. This is point P here. Okay, this is point P. Now from this point to this point, you are going to get two values. What are the two values? Vxt plus x prime. So here if you add these two values, this will be equal to x. Okay, that is a thing we are going to mention. Okay, if you consider x here, let me take other color. Okay, now if you take x from the diagram, now it is equal to x prime plus vxt. Okay, so that is the thing we got from the diagram. If you want, you can refer back once again. So here x equals to, okay, vxt t plus x prime. If you add these two, then you are going to get this. Let me do one thing. X is there. So x is there here. Let us go with this. X equals to, now up to certain point you are getting Vt. Okay, next thereafter you are getting x prime. So if you add these two, you are going to get x. Okay. Now instead of drawing this, we are going to write in the form of equation. Okay, from the diagram. Now the same thing we wrote here. So x equals to x prime plus v suffix xt. Now here we are going to arrange this in terms of x prime. So if you rearrange here, if you bring this particular factor, you bring this factor to this side, bring this to side, then what happens? You will get this as x minus, okay, vt. Suffix x is there. That is the meaning of x-axis. Okay. So what is the thing here? X prime equals to x minus vt. Okay, velocity is there towards the x-axis, so suffix x is there. Now here, what is this equation? It is a relation between x prime and x. Okay. Now why you are getting this? Because the frame has moved. Okay, if the frame is at the same starting position, then what happens if this second frame has not moved any distance? If both the frames are concentrating on the same point, then what happens? This will become 0. This will be 0. So this term will not be there. Okay. Then what happens? You will get only x prime equals to x. Under what conditions? If both the frames, okay, if both the frames, this is the second frame is also there, it comes back the same origin, then what happens? There will be no distance, so that this particular factor will be vanishing. Okay, so that is the thing here. We got the relation between x prime and x, considering the distance of separation between the two frames. Now similarly, what we are going to get, okay, you can have the similarity. Y prime equals to y minus vt. Okay, suffix y is there. Now z prime will be equal to z minus vt. Okay. Now here what I mentioned, both the time periods are same. You are observing the event at the same time. So that's why both the time periods are same. So I wrote the same thing here. You can refer to this note here. We assume that the time of occurrence, okay, of the event is same in both the frames. Okay, that is the reason here we mentioned t equals to t prime. What is the meaning here? Which means that the time is same for all the inertial observers. Both the observers will be observing the event at the same time. Okay, so that's why you are getting no change in the time. Now here we got these equations, 4 equations here. Now we are going to use first equation, second equation and third equation. Okay, now here these are the positions. If you got the position, then you can find the velocity, and if you find the velocity, you can find the acceleration. So now the thing is that you found the x, y, z in the, or x prime, y prime, z prime in second frame. So those are the positions. Now what we are going to do? We are going to find the velocity. Okay, first part will be the velocity. We are going to find the velocity, and thereafter we are going to find the acceleration. So how can you find the velocity? Velocity is nothing but the rate of change of distance. Okay, so we are going to differentiate, okay, the above equations with respect to time. Okay, then you will get the expression for velocity. So the same thing here. Now consider this equation. Consider this equation. What is the equation here? X equals to, or x prime equals to, okay, x prime equals to what you got? X minus Vt. Okay. Now this is regarding the position of the event from S prime. So you got the relation between the coordinates of S prime at the point P, coordinates of point P in S prime, in comparison with the coordinates in S frame. Now what we are going to find? We are going to find the velocity. So how can you find the velocity here? You consider this equation here towards your left side. You differentiate here with respect to time. So d by dt. Okay. So dx by dt means what you are going to get? You are going to get the velocity. So both sides you have to differentiate. Both sides you have to differentiate. Okay. Then you will get the equation converted into the velocity. Now same thing here. We are differentiating the left side with d by dt. So now here you got dx by dt. Okay. And here t is there. In the equation you got t, Vt. So Vt means here if you differentiate what happens, dt by dt means you'll get 1. So that's why here you are going to get Vx. Okay. dt by, here it should get like this, dt by dt. So here what happens, this will be equal to 1. So that's why instead of that derivation part, I had erased that part. So you'll get just like this. Okay. So now here this is the velocity, okay, of the event in the S frame in relation with the velocity in the S prime frame and the S frame. Now regarding the y dash and regarding the z dash, you will get these three equations like this. So I'm repeating the point here. Depending on the two frames as shown in this diagram, first you will find the relation between x prime and x, okay, y prime and y, okay, next z prime and z. Now depending on the geometry, you got the relations like this. What are the relations here? X prime will be equal to x minus vt or vxt, y prime equals to y minus vyt, next z prime equals to z minus vzt. Okay. Now from these three positions here, we are going to convert, or we are going to obtain the velocity by differentiating those equations with respect to time. Now thereafter you are going to get three equations, okay, 1, this is 2, okay, and 3. Simple mathematics, there is no difficult to understand these. Okay. Now what we are going to do, we are going to convert this particular left hand side as u prime x. Now this as ux. Okay, you can understand what is these. So it is a velocity in S frame. This is a velocity in S prime. And what is x here? It is a movement of frame, second frame, or between those two. You got the movement. Okay. So that's why this is a velocity, constant velocity of the movement. Now similarly, the velocity regarding y-axis and the velocity regarding the z-axis. Okay, so now here you got the three equations representing the velocity. Now you got the relation between the velocity in s prime, and here this is a velocity in terms of s frame. Okay, now if you are going to write the resultant equation in terms of I cap, j cap and k cap, okay, so you can find the resultant equation like this. Okay, the same equations, we had added all these three. So if you can go with this, this is the left hand side, this is left hand side here. Now here this part will be the right hand side, this is the right hand side, RHS. Now what we did towards the left hand side, we added all the three factors. Okay, three factors we are adding. Okay, and here the three factors. Now we are representing the axis. What are the actual axis? Okay, now here this gives the equation of velocity of second frame, which is equals to the velocity of the frame, which is s, okay, minus the velocity of the second frame which is moving. Okay, the same thing that we got in this equation. So we are going to write this as capital U prime equals to U minus V. Okay, now what are these particular things? This gives the velocity of the second frame with respect to the first frame. Now these equations represents the Galilean transformation of velocity of a particle, whatever the event or the object we are considering. Okay, those velocities are there, we consider these as the Galilean transformations. I hope you got the points. A simple mathematics, nothing is there. Okay, just we had started with the previous concept that we had explained in the yesterday's class. Okay, we had considered a frame S frame and the S prime frame. We labeled as XYZ for the first frame, second frame as X prime, Y prime, Z prime. Okay, and we mentioned that the second frame is moving with some velocity V, constant velocity. As a result, you are getting the coordinates, okay, of this particular frame, or the, let us go with this as the event here P. Okay, now you are getting two different coordinates. What are the coordinates here? Regarding S frame, you are going to get XYZ. Regarding S prime frame, you are going to get X prime, Y prime, Z prime. Okay, thereafter what you did, you got the relation between the coordinates, both the coordinates. So is there any doubt? If you are having any doubt, you can express in the chat box. Let me check the chat box once. Now we had seen the position and the velocity. Now we will convert the velocities into acceleration. So how can you convert the velocity into acceleration? You will take the differentiation of velocity with respect to time, d by dt of u, the velocity. Okay, so this gives the acceleration, a equals to du by dt or dv by dt. The same thing here, the previous expressions you got in terms of velocity. Now we will convert that velocity into acceleration by differentiating. So the entire topic is having three parts. Okay, in the first part you are getting the xyz coordinates, okay, and x prime, y prime, z prime coordinates and their relations. Second part is having the velocities. You are obtaining the velocities by means of the coordinates. Third part is that you are going to get the acceleration. So how you get the velocities? By differentiating the coordinates with respect to time. Now how you are going to get the acceleration? You are going to differentiate the velocities with respect to time. So here this is the equation. So previous equation you got u equals to or ux equals to or ux prime. Let us take this as x here. Ux prime equals to ux minus vx. Okay. Now what we are going to do? We are going to differentiate this equation with respect to time. Okay. So that is going to give the acceleration. Okay. Now here this gives the acceleration in s prime. Okay. Next, this gives the acceleration in s frame. Now the question arises, why this factor has become 0? Why it is 0? Okay. What is the reason here? We are getting this factor Vx. What is Vx? Vx is a constant. It is a velocity which is constant or the uniform velocity. Vx is constant. It is not changing. So if you differentiate the constant, what happens? You are going to get 0. So that's why you got the differentiated value as 0. Okay. So what actually Vx? Vx is the velocity of the movement of second frame. Okay. So this velocity is constant. The second frame is moving with some constant velocity. So as this velocity is constant, you cannot differentiate. You are going to get a 0 value if you differentiate the constant value. So that's why, what is the conclusion here? The acceleration in the second frame will be equal to the acceleration in the first frame. So what is the conclusion here? Both the accelerations are remaining same. Okay. Whatever the acceleration you are obtaining in the s frame will be equal to the acceleration in the s prime frame also. So if you consider another s double prime, there also you will get the same acceleration. So there is no change in the acceleration. Okay. So now here, what is the conclusion you can mention here? There is no variation. So that's why it is invariant. Okay. So that we will conclude in the next class. I will see the small remaining part regarding the second law. So here what actually second law is, second law mentions that f equals to ma. Okay. A small part is remaining that we will see in the next class. So what is the thing here? F equals to ma. Now here what we mentioned here, the acceleration is remaining constant. Acceleration is remaining constant. So that we are going to mention and we will conclude the topic. So as the acceleration is remaining same in both the frames, we will conclude here it as invariant or invariance. There is no change. Okay. So that is the thing we are going to conclude, that we will see in the next class. Now I will repeat the points whatever you had learned today in the today's class. Okay, just let us see here what we had started. Okay. Now we had started with the frame here. Both the frames S and S prime. Let me check once in the chat box. Is there anything? Okay, now we started with the two frames, and we mentioned that the second frame is moving with some velocity. So here this is a velocity here, we mentioned here v is the velocity. Now velocity is regarding the second frame only. Okay, the second frame is moving from point O. Initially it was at point O, but now it has moved, okay, with some constant velocity v. Okay, now as it has moved with some constant velocity for a particular time period of t, okay, there will be a displacement between the two frames. So that particular value can be obtained as v into t. So as it is considered in the x-axis here, you are going to get the suffix as vxt. Now regarding the y-axis displacement, you will get vyt. Okay. Similarly, there should be the third factor also that I didn't mention completely here. So to avoid the confusion, I wrote only regarding x and y. Okay. So actually, you can refer here. I wrote regarding the velocity. So other things I didn't mention completely. So to avoid the confusion, I deleted those things. You assume that the third things also there, third dimensional things also there. Okay. Now here, now v is a velocity, constant velocity of the second frame. Now as it has moved, okay, for particular time, this is a distance. Now what is the thing here? You found a point P which is common to this both the frames. Now you found the distance from the first frame and the point as x. Okay, next you found the same point at x prime, okay, from the second frame. Now from the geometry, what you are going to give? The entire distance from this point to this point, between these 2 points. Okay, I'm writing drawing like this. So this is the entire distance here between point P and the S prime, the S frame, which be equals to this. Okay, and here this plus this here v regarding the vt. So if you add these two, you are going to get the x. Okay, that we wrote in the form of equation. Okay, this was the equation here. X equals to x prime plus vt, and we had converted the equation. Let me check once. I will reopen this. Okay, so now here this was the thing we got from the geometry using the previous diagram. Now we are going to rearrange here, just rearranging. Okay, x, we are leaving x prime here. Okay, so you are bringing this factor to this side. Okay, and you will get the minus. So here you are going to get the expression for x prime. So similarly, you are going to get y prime, z prime. Now what we had seen that t prime is equal to t. Why you are considering both these are equal? Because from both the frames we are referring the event at the same time. Okay. Now that's why you got these 4 equations. Now using these 3 equations, first 3 equations, you are going to convert this one into velocities. So how can you convert these equations into velocities? If you differentiate this side, okay, with respect to d by dt. So you are going to get this one as the velocity. Okay, so that's why we are going to the topic of velocity. So you are differentiating the above three equations and you are going to get this. Okay, and here these two remaining equations. Simple substitution. You had converted the position into velocity. So these are the three equations you are going to get. Now from there, you had converted or you had given the relation here in terms of u. Okay, velocity. You had converted this particular part into the velocity you had represented in terms of u. And this has uy. Okay, regarding the y-axis. And here regarding this, we are going to write this as u regarding z-axis. Okay, this is regarding the z-axis. Now the same thing here towards this, you will write this as ux, and here as it is, this factor as it is. So these three equations represents the relation between the velocity in s prime frame and s frame. Now here you are getting the velocity. First you started with the position. These three equations will give the position here. Okay, and you had converted those three into the velocity. Okay, then if you differentiate these velocities with respect to time, you are going to get the acceleration. Okay, you had differentiated those three equations and you got the acceleration. Then what is the conclusion in this particular thing? The acceleration in both the frames is remaining same. Okay, so that's why what you concluded, even though the frames are moving, as those are inertial frames, okay, the acceleration is remaining same. And thereafter we are going to conclude in the next class about the invariance of the Newton's second law. So as the acceleration is remaining constant in both the frames, so what is the conclusion that we will see in the next class, upcoming class? A simple conclusion is there. Just we will need the variation only, just comparison only. Okay. Now if you are having any doubts, you can raise your hands so that I can unmute you. So time is same. That's what I mentioned. Time is same means we are referring the same event from both the frames at the same time. Okay. We are referring the event at the same time. Please raise your hand so that I can unmute you if you are having any doubts. Okay, no doubts. What about other members? Are you able to understand or not? That's what the question I am getting. I didn't got the clarity. Now here only few members submitted. Okay, 123 said no doubts. Okay, that's okay. Now only few members submitted the assignment. So every time I am not going to repeat about those things. If I mention the time means that particular period, in that particular time duration only you need to submit, and I extended the time for late submissions till yesterday. Few members submitted yesterday also. Depending on your the submissions, you are going to get the marks allotment, assignment marks. So I'm unmuting 138. You raised your hand, so I'm unmuting from my side. Okay, 162 said no doubts. 107 no doubts. Okay, 174 I am newly joined. Okay, whatever it may be, newly joined means the topic, whatever you had seen today or yesterday, okay, that might be giving a clarity. If you are newly joined means you can refer back to the recorded videos. If you can check the links, video links, so there you can refer back to those videos and you can verify what the things that we had studied in the previous classes. Okay. I had unmuted 138. If you want to speak anything, you can speak. Assignment date, actually it was on Saturday itself, previous Saturday. Okay, tomorrow we will see the conclusion of this particular topic. So what was the topic we had learned? It is a form invariance of Newton's second law. So just we need to conclude about the topic. When can I submit it, sir? Okay, as you are newly joined means you refer back to the videos and you submit on today is Wednesday, I think. Okay, let me do one thing. 174. This might be the last number, I think. So I can remember this easily. 174. You can submit on Saturday again. Today is Wednesday. You refer back to the previous videos, or you can take the help of your classmates. Okay, try to discuss with those members. Now, better the thing is that you can refer to the videos, the recorded videos, so that you can get the clarity about each and every subject, not only my subject. Okay. No. I cannot send the videos because actually, if you can refer back to the your login, you might be get the video links also. Regarding assignments, you can send it in the format PDF format, so that it will be easy to verify. Instead of sending single images, you club those all the images of your assignments into a single PDF. You can use the cam scanner or else Adobe scanner as mentioned yesterday. I had mentioned yesterday also. Same thing. On Saturday you can submit. 174. As 103 I had referred your PDF. I had sent the PDF to him. Send the PDF to him. Okay, 103. Okay, then 174 you can refer those particular things as well as refer the previous notes that I had shared in the WhatsApp group, or else you can refer back to the textbook. Any textbook is there if you are having any senior members are there. That's what I mentioned. You had shared the notes with the newly joined member, I think. That was the meaning I think I got. Okay, okay.